So let's do the integral of cosine fifth of x. There's no obvious substitution we could do here, but recall that the derivative of sine of x is cosine of x. So if we could rewrite the integrand as a bunch of sine x terms multiplied by a single factor of cosine x, we could easily substitute u equals sine of x. The exponent in cosine fifth of x is odd, since 5 is odd, which means we can easily rewrite the expression in the form I just mentioned. If we rewrite this as cosine of x times cosine squared of x all squared, we can use the identity cosine squared of x equals 1 minus sine squared of x to rewrite the integrand as cosine x times 1 minus sine squared of x all squared. And keep in mind that this identity comes from the Pythagorean identity. It comes from the fact that sine squared of x plus cosine squared of x equals 1, and if we just subtract sine squared of x on both sides, we just end up with cosine squared of x equals 1 minus sine squared of x. So I just rewrote the cosine squared of x all squared as 1 minus sine squared of x all squared. So since the integrand consists of a single cosine x term multiplied by an expression entirely in terms of sine of x, we can easily do the substitution u equals sine of x, which means du equals cosine x dx, and if we substitute this back into the expression, this just becomes the integral of 1 minus u squared all squared du, since cosine x dx becomes du, and since u equals sine of x, 1 minus sine squared of x all squared is just the same as 1 minus u squared all squared. If we expand this expression, this just becomes the integral of 1 minus 2u squared plus u to the fourth du, and we can just integrate this polynomial term by term. The integral of 1 is equal to u. The integral of negative 2u squared is negative 2 over 3 times u cubed, and the integral of u to the fourth is u to the fifth over 5. And we have to add the constant of integration c. And since we let u equal sine of x, if we substitute the sine of x back in for the u, it just becomes sine of x minus 2 over 3 sine cubed of x plus 1 over 5 times sine fifth of x plus c. So the integral of cosine fifth of x is just sine of x minus 2 over 3 sine cubed of x plus 1 over 5 times sine fifth of x plus c.